Good morning one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 Module 4 Lecture Series 7 for 6th semester students under the heading of Bearing Capacity of Shallow Foundation. Today we are discussing about field method of determining the bearing capacity of soil by using a SPT test, standard penetration test. So there are several tests which are used in practice to determine the strength carrying capacity of the soil in the field. However, there are two tests which are gaining more popularity than other tests as on today. Number one, SPT test. Number two, plate load test. So now, first we should consider what are the things will be there in the SPT test assembly. Next step is how to prepare the ground for conducting the test. Third one is procedure for conduction of the test. Next one is correction to applied SPT value. Last one but not the least, calculation of bearing capacity by Tang and Peck equation. So now first we will see what and all the things will be there in the SPT assembly. One is 65 kg hammer. Strictly speaking 63.5 kg hammer will be there, but generally they are using 65 kg hammer, but code specifies 63.5 kg. In practice it is 65 kg hammer is used because by taking all the whole losses into consideration. Next one is we will have a cutting edge which is having an internal diameter of 30 mm and external diameter of 50.8 mm. Internal diameter 38 mm, external diameter 50.8 mm. So which gives a thin wall sampler cutting edge effect. And a split tube will be used. Split tube means, so this is your cutting edge and this is your split tube. If you cut it, you can make the tube into two halves. The length of that split tube is 60 centimeter. Inside the split tube, we will have a brass shell bay tube. So where sample will be collected whenever it is driven into the ground. Next, in order to lift the 65 kg hammer and to drop it from a height of 75 centimeter, so we require a tripod stand with a pulley winch assembly. So for effective application of impact load. This is the requirement of SPT test assembly. Second thing is preparation of the ground. How to prepare the ground? So wherever the SPT test is to be conducted, the top surface of the soil vegetation is to be removed. Point number one. Point number two, a casing pipe is inserted. By using auger, boring will be done up to a certain depth at which the SPT test has to be conducted. For example, I want to conduct SPT test at 1.5 meter below ground level. We will not do SPT test from 0 meter up to 1.5 meter. We will start at 1.5 meter only. Therefore, up to 1.5 meter, make a boring by using any conventional boring technique. Generally, it may be auger boring or it may be a wash boring or shell boring, etc. Afterward, depending on the soil, insert the casing pipe. Once the casing pipe has been inserted, inside the casing pipe, cutting edge, split tube sampler with shell bay tube and an extension rod. So this is your cutting edge, this is your the split tube, inside you will have shell bay tube, and again top it is connected to the extension rod, and that rod height of fall will be adjusted to 75 centimeter. One rod will be fixed. Inside that rod, a dropping weight of 63.5 kg is fixed, and everything is connected to a tripod stand. On the top of the rod, here, this is your cutting edge, split tube, and this is the extension rod. This is the dropping weight. Drop of the rod, so the height of fall will be adjusted to 75 centimeter. 15 centimeter 3 marking with chalk piece will be done on the top. So this is about your test that is the site adjustment. Coming to the conduction of the test. So conduction of the test means if we lift this weight and if we drop it from a height of 75 centimeter on the split tube sampler, because of this dynamic effect, this tube will start penetrating into the ground. One time if you lift it and drop it, it is called it as one blow. So likewise, you have to calculate or you have to count how many number of blows required for 30 centimeter penetration of a split tube sampler beyond 15 centimeter of seating drive, which is called as N value. So I will repeat it once again. N value is defined as number of blows required for 30 centimeter penetration of a 38 mm internal diameter, 50.8 mm cutting edge with a 60 centimeter split tube sampler with the help of 65 kg rammer with a height of 75 centimeter free fall beyond 15 centimeter of seating drive is called as N value. So count the N value. Afterwards, as this tube penetrates, soil will start entering in the upward direction and soil will collect here. Once the 45 centimeter penetration is completed, count how many blows required for 30 centimeter penetration and then take out this tube and remove this split tube. You will get the sample, take out the sample for UCC test determination or triaxial test determination purpose to find the shear strength parameters. Next is, whatever the N value is obtained according to IS 2131 1981 class 3.6, it has to subject it to corrections. There are two types of corrections are recommended by IS code: correction to overburden pressure and correction to dilatancy. Correction to overburden pressure is NC is equal to Cn into N0, where N0 is original number of blows required for 30 centimeter penetration in the field beyond 15 centimeter of seating drive by using 65 kg rammer with a 75 centimeter free fall, where Cn is equal to 0.77 log base 10 2000 divided by sigma, where sigma is gamma into h. Gamma is density of that soil, h is depth at density of this soil, depth at which we are conducted this test, and this gamma into h should be less than 25 kPa. If it is greater than 25 kPa, we have to consider it as 25 kPa. Then whatever value you will obtain, 0.77 log base 10 2000 divided by sigma, that value you have to substitute it as Cn, that is correction factor to N value. If you multiply it by actual number of those, will give NC. Once you get overburden correction, next we have to go for correction to dilatancy. The value obtained in the above equation to be corrected for dilatancy if the strata consists of fine sand. This is very important. So very important for fine sand and silt. If it is fine sand and silt, then only you have to do this correction, otherwise it is not required. Below the water table, so for NC is greater than 15. So NC is equal to 15 plus half of NC minus 15. NC dash is equal to 15 plus half of NC minus 15. Next, according to Terzaghe and Zepek in 1967, the bearing capacity is given by formula QP. Allowable bearing capacity is equal to 35 into NC dash minus 3 into B plus 0.3 divided by 2B whole square RW2 into RW into RP. So where RW is equal to half of 1 plus ZW2 divided by B. RD is equal to 1 plus 0.2 dF by B, which should be less than 1.2. If it is greater than 1.2, consider that RD value as 1.2. If you substitute it, you will get bearing capacity in terms of kilonewton per meter square, and which also gives a 25 mm permissible settlement bearing capacity value. So now let us consider a problem. A strip footing 1.2 meter wide is located at a depth of 1.5 meter in a non-cohesive soil deposit for which the corrected N value of SPT is 20. So here they use the corrected N value verbatim. Therefore, you need not necessary to go for correction to overburden pressure and correction to dilatancy. Water table is located at a depth of 2 meter below the ground surface. Here the strip footing is 1.2 meter wide and water table is at 2 meter depth. So find the allowable bearing capacity of the soil. So first and foremost thing is you write down what they are given. They are given sand. Type of soil is sand and B is 1.2, DEF is equal to 1.5 and water table is 2 meter. So NC dash is equal to 20 according to Tezague and Peck in 1967. So the bearing capacity is given by formula QP is equal to 35 into NC dash minus 3 into B plus 0.3 divided by 2B whole square RW into RD kilonewton per meter square, where RW2 is half of 1 plus ZW2 divided by DF, that is 0.7, RD is 1 plus 0.2 DF by B, that is 1.25, which should not be greater than 1.2, so substitute it as 1.2 only. So then your QP value will be 198 kilonewton per meter square. Take one more problem. Determine the net bearing pressure for a 2 meter by 2 meter footing at a depth of 1.5 meter in a medium dense sand, so that the total settlement does not exceed 25 mm. The average SPT below the footing are 20 or 30 centimeters. The average moisture unit weight of soil is 17 kilonewton per meter cube. The water table is at 5 meter below the ground level. What will be the bearing pressure if the water table rises up to the base of the footing? So here the given values you have to mark it. Number one, the size of the footing 2 meter by 2 meter, so B is equal to 2 meter. Depth is 1.5 meter. Medium dense sand is given. So as I said earlier, so if I go back to my discussion, find sand, so consists of sand and silt. So okay, so here it is a medium dense sand. So please keep it in mind. We will discuss it later. Medium dense sand is given and the total settlement is 25 mm. 25 mm settlement, if you want to get directly, means it is by only by using the Peck equation, and the indirectly they are given the SPT value at 30 centimeter. Instead of n value they are given it as in a verbatim 20 for 30 centimeter. So n is equal to 20. The average moist unit weight, the gamma is given saturated. Water table is 5 meter below the ground level. So your depth of foundation is 1.5 and your footing is 2 meter. 2 plus 1.5 is 3.5 meter. Still there is a lot of space is there to start the water table location. That means your water table does not have any effect on the bearing capacity. Let me see the equation. So now the Peck equation is that QP is equal to 35 into MC dash minus 3 into B plus 0.3 over 2B whole square RW into RD. So here RW2 is half of 1 plus ZW2 divided by B, that is equal to 1. RD is 1 plus 0.2 DF by B, 1.15 less than 1.2. Next, NC is given 30, NC dash is equal to 30. This equation is valid for fine sand. The question gives dense, medium, and hence NC is equal to NC dash is equal to 30 only. So the equation whatever they are given, it is only valid for fine sands. They are given medium sand, so hence the NC is equal to NC dash is equal to 30. No need to apply any type of correction. So if you substitute in the above equation, the QP is 315 kilonewton per meter square. Case 2 you will see when the water table rises up to the base of the footing, when RW2 is 0.5, QP if you substitute in that equation 179.5 kilonewton per meter square. The MCQ questions are: these tests involves the measurement of resistance to penetration of a sampling spoon, a cone or other shaped tool under dynamic or static loading. So it is false statement. The resistance is empirically correlated with some of the engineering properties of soil such as density index, consistency, bearing capacity, etc. The resistance is false. The number of blows required to drive the sampler tube to a depth of 30 cm beyond the seating pressure of 15 cm using 65 kg hammer with a 75 cm free fall, termed as N value or SPT value, is true. The option is A. Corrections. Correction for observed n value is according to IS 2131/1981 class 3.6 guideline. Two corrections are to be applied: correction to the overburden pressure and correction to the dilatancy. So that is true. And correction to the overburden pressure according to IS guideline are to be applied for correction to the dilatancy. Yes, it is true. Bearing capacity equation is PT test is 25, they are given NC dash minus 3 is 35. So option is B. 7% bearing capacity is given by, so by SPT test given. So that is the answer is true, A. Next is the QP is 45 into NC minus 3 B plus 0.02 B was already, that is 45, that is option is B. That is wrong. So next is 35 into NC4, that is NC3 is a tech equation, it is NC4, therefore it is option is B. Next is 35 into NC dash 3 B plus 0.02 B. Instead of 2B they are given 4B, therefore the option is B. It is not correct. So these are the list of references we are used to prepare this particular module. I take this opportunity to thank Department of Collegiate and Technical Education and students for giving me an opportunity to deliver the lecture in this particular area. I hereby inform all the students to go through the LMS content of this topic, and if you have any doubt, you feel free to ask.